So let's start with the product property or the product rule of logarithms. So when we are deriving these formulas, we will be moving on the product rule. We will be moving we derive from the left side to the right side. Okay. So first of all, we need to, we see on the left side we have x times y. Okay. So first of all, we need to find x and y, and then after finding x and y, then we multiply them and we introduce log. So the way we do it is we let m or any, it can be any alphabetical letter, we let m be equal to log ax, and we also let n, they just choose n, be equal to ay. Okay. Since our intention is to make x disable the formula, we have to move the base a to the left side of the equation. When we move base a to this side of the equation, m becomes a power and m is still a base because it's now in the exponential form. So what happened is when we let x to disable the formula, a move to the left side of the equation. Now we have a to the m. So in general, logarithms, they are sort of alternatives to exponentials. They are sort of inversely, they are sort of inverse to each other. So when we make y disable formula on this side, the approach is the same. A moves to the left side of the equation, it becomes a power, n becomes a power. So now we have a to the n. Okay. So now we have our x and our y. So now we should multiply x and y. So when we multiply x times y, which is the same as a to the m times a to the n, we can further simplify this expression here as a times m plus n, because by the laws of exponents we know that if the terms have the same basis, a and a, we can add their powers, m and n. So now we have x times y, which is a to the power m plus n. So I need you to take a closer look. That's why we had to, okay, it's because we have the same basis, which allows us to apply this concept here. And because we have an exponent with base a, which means when we are introducing logs to our equation, we have to introduce a log with a base a, so that it also meets the requirement of our equation, because our equation is logs in base a. So when we introduce logs to this equation, we'll introduce a log with base a on each side of the equation, so that our equation remains balanced. And also it becomes easier to simplify further our equation. So now we have log a x times y, which is equal to by another law of exponents before we proceed, which says log a to the power xy is the same as y log x base a. Okay, so what we've done is we moved the power of the log behind the log itself. So this is known as the power rule. We will do that as well. So that's what we will do on this part as well. So we just take this as a single power and we move it we move it behind the log itself. So when we do that, we now have m plus n log, or this is in brackets, log a. Also, by another property of logarithms, which is usually referred to as the identity rule, or let me use the identity rule, which says that log a is 1. So this is the identity rule in case that the logarithm itself and the base, they are the same letter, or when they are the same number, the result will be 1. So they are sort of identical to each other, the base and the log itself. Okay, so now we have log a x times y is equal to m plus n all in bracket times 1, because this part becomes 1, log a, as we have indicated with the identity rule. Okay, so as we have seen earlier on, as we have declared here, we stated that m, let it be log x base a, and n, let it be log y base a. So we simply have to substitute m in place of m and n. So now it becomes log a x times y to be equal to log a x plus log a y. So we have finally arrived to our final solution. So that's how we derive the product rule of logarithms. So moving on to the second rule, or second property of logarithms, which is the quotient rule. So this property is similar to the product rule, but in this case we are simply dividing x and y. Yeah. So as we have seen earlier with the product rule, we are moving from the right side of the equation to the left side of the equation. So the process will be the same as we have gone through earlier. So as I said, you can choose any letter, but I would prefer to use m. So m is equal to log ax, and also if n to be equal to log ay, right? And this no, let me use this. Then we make x a formula which becomes an exponential function, or maybe an exponential equation sort of, and we also do the same for y. And y a moves to the left side of the equation, it becomes a base, and n becomes a power. We have a to the n. Okay, now we have a x and y, and from this equation we are dividing x and y, right? So we are going to divide x over y, which is the same as a to the m over a to the n. And also, now since we are dealing with exponents, we apply the laws or properties of exponents. We say that if we are dividing m and n, we have to simply subtract. If we are dividing like terms with the same basis a and a, we have to subtract their powers, which is m and n. Okay, so now we need to introduce logarithms now to our equation. So as we have said earlier, we should introduce bases with this logarithm with the same base as shown in the equation which we need to prove. Okay. So we introduce a logarithm with base a, and so that when we move this power behind the logarithm, we are left with sort of an identity. We can apply the identity property of logarithms to eliminate log a. Okay, because we have a base A. So now we have log A x over y to be equal to m minus n, all in bracket log A base A. And of course, this part becomes 1. Now we have log A x over y to be equal to m minus n. Of course, this part becomes 1. And as we have reasoned here and said x is now m is log x base A and n is log y base A, we simply have to substitute in place of m and n. So now, which means we have x over y to be equal to, as we said, m, we said it's log A base x. Log x base A, and n respectively is y base A. So we have actually arrived to the final solution. So the power rule, as we have seen earlier, we are moving from the right side of the equation to the left side of the equation. So the power rule, we are just going to prove that this side is the same as this side. Yeah. So first of all, we can choose any letter. I prefer m. So I let m to be equal to log ax, log x base A. Okay. And since on this side, you see, we have x to the power y. So first we need to find x and then we raise it to the power y. Okay. So now x becomes move to this side of the equation, becomes a power, m becomes a power. So we are just transition from logarithms to exponentials. So since we have x now to be equal to a to the m, as we can see from this equation, x is raised to the power y, so we should simply multiply everything with power y. So power everything is multiplied by power y. So now we have x to the y is equal to a m to the y. And we simply have to introduce log A and log base A and log base A to every side of the equation. So now we have log A x y is equal to we can, since this is a my is a, since my is a, or let me use it different. Since my is a power, we should move it behind log. So now we have my log a, and by the identity property of logarithms, we know that log a base A is 1. So now we have now we have log a x power y is equal to my, and we can also do the same on the left side of the equation. We have log a power x. So we are just moving the base behind the logarithm, that's all. My. Of course, we can divide y. Now m is equal to log x base A. So yeah. Oh, sorry. So that's the proof, because like this, as we had declared earlier, we said we said on this part. We said m is equal to log ax, and that's what we did here. M is equal to log x base a. That's the same thing. So it's sort of proving what we have already stated here for the power rule. Okay. So this is an interesting part of logarithms where we have to change the base. Okay. So with this property or rule, we are a does not, we change the base a to base b. So the way, so you can change b can be any, it can be or base c or base z, like you can choose any letter, but here I just chose b. Okay, so here the way we derive this or the way we change bases, we move from the here we move from the left to the right. So the way we do it is first we can choose any letter, but here let me choose k now. Okay, so k is log a, is log x base a. Okay, so since our intent is to remove a as our base and to introduce a new base, we have to sort of make x the separate formula, because by making x the separate formula, we know that a becomes an exponent, a base, and k becomes a power. So we have an exponent. Now we have an exponent. Now instead we moved, or we have transitioned to an exponent form instead of the logarithmic form. So we have k x is a to the k, right? So now a is not we can introduce logs now, since we now introduce logs with different base, since now this is now in exponential form. It gives us room to introduce, let's say, base b, since in this equation, as you can see in this equation, we had base b, so we have to introduce a log with that same base for us to arrive at this answer. If you wanted, if your log was base c, which means your log here, you have to introduce logs with base c. If it was z, then you have to introduce logs with base c. So base b, this is all in brackets. Okay, so by the power rule, as we have already seen, it becomes log bx. This becomes k log b a, right? And we make k the separate formula. So if we make k the separate formula, we have log x base b over log b base a, log a base b to be equal to k. So you see now a is no longer a base, but b is a base. And as we have we stated here earlier on that, let me use a different ink to on this part, where I said k is equal to log x base a. So we can substitute in place of k, we can substitute log x base a. So k is equal to log x base a. We simply substituted. So by substituting, we have actually changed the bases. So our final result is now log x is actually equal to log bx over over log ba. So this is our final result. k. Okay, so for this part I just want to add some interesting logarithm properties. Some I've already said them. For example, the identity property, which is log AA, which is 1, and the other is log A1, log A1 is 0, and this log property, log AA, is the same as lin E, like they give us the same result. Lin E is 1, and I think lin 1 is 0, sort of, yeah. And the other one is the other one, we call it the log of exponent row, which is if I say log B, it's almost the same as the power row, but like the log of exponent, because like this part b to the k is an exponent itself, sort of an exponent, so it gives us the logarithm of a base to a power row. So that it gives the power is, yeah, of course we know, like you have to move the power to the behind the logarithm itself, right? So the other which I can include is, yeah, for this I should have stated that a should be greater than 1 for this part. A should be greater than 1. Make sure everything is above 1. Okay. And the other one which I can include is okay, there's another one which says a log, let me use a different ink, a log a to the x is equal to x. Okay, this is an interesting property. So we need to prove this part, like how so we need to prove. Okay, so how did we arrive to x? Like how can we say it's x? Okay, so first of all, we can say let's let log a to the x, right, be equal to okay, to say n, we can say n or any letter, it doesn't matter. So our goal is to okay, let's I will explain later. So now we make x the separate formula. So we are sort of moving from this side of the equation we are moving from the right side of the equation to the left side of the equation. So now we have x to be equal to a to the n, right? So x is equal to a to the n, which is the same as here n is the same as log a to the x. So we can say x is actually log ax, is still the same thing. Okay, the other one is which can be of, okay, the equality property, where we can say log ax, if log ax is the same as log ay, which means x is equal to y. This is the equality property of logarithms. Or I think this also can hold true if x is equal to log ay, which means our bases are also the same. I think it's still the same thing. And another interesting property is the inverse when It's okay. Let me use a different ink. It's log AB times log BA is 1. Okay, because we know that log BA is still the same as 1, this as log AB is still the same thing. So this is an interesting property. We can actually prove this one. So let's actually prove this property. Okay, now my page. Okay, I'll just do it on this part. So we'll just continue. So okay, let me just add a new page. Okay, so we need to prove this property. We have already seen by the property of changing base, where I said log AX is the same as log X B over log A B. So which means we can also do the same and say log B A base B is the same as log A base A over log A base B is still the same thing, because like it doesn't matter, like as long as the bases are the same. So which means we can actually apply that property here, and this is the same as 1 over, this is the property of identity, 1 over log AB, right? So which means now we can say this is the same as 1 over, and in place of log AB we can substitute this what we have already got here, which is this part. So it's 1 over 1 log AB all in brackets. So which is the same as 1, since 1 is being divided by 1 over, we are dividing 1 over log AB, which means is the same as 1 times log AB, which is, so when you are multiplying, you should just invent. You invent 1 comes down and log B base A goes upward. So 1 times log B base A is the same as log B base A. Okay. Another interesting logarithm is log A to the power M and log A to the power N. They give us M over A, and in this case M is not 0. Okay, so let's also prove this logarithm using those properties as well. So the way we can solve this logarithm is we already have a power here. So okay, this is the same as log A to the AN over log A to the AM. Okay, we just use the property of changing powers. So here I just express over the same power A. You know, if you still remember the property of powers, okay, I will just repeat it, which is still B. Here I just said B, but it can be any letter, BA. So it's still the same. I just use the same property. So if I have this property, I can say since this is power N and this is power N, not the power same basis here. I mean like a and a, there's a and a. If it was b, maybe it will be a different case. Okay. I mean like we wouldn't be able to apply the identity power, because if I had b here, okay, I'll explain that later. Now let's just simplify our logarithm. So which is n over m, because this one they simply cancel out, or is just 1 over 1. Okay, what I was trying to say is, if it was log base a power m, and here we had b n, like if it was b instead of a, like b and a, like they are not the same, then our result will be the same, won't be the same. If we had applied, maybe it would have been log a b power n over log a power m. Of course, like here a and b, we cannot apply the identity property. Of course, we'll be left with n log b a over m. Okay, we just moved m behind the base here, and log a is 1. So this will be our sort of our result. But here I'm just for n over m, it's for this question here with log a or n base a to the m. Okay. Okay. That's another interesting property. It's not a sort of a property, but we can use the property which we have already gone through to solve the problem. It's log a 1 over b is the same as minus log a to the b. Of course, we know that log a 1 over b is the same as b over 1, and that's why it moves here. So another thing which I wanted to say is log base, whatever base, and if we have a negative number inside the logarithm, of course it's undefined. It's undefined or cannot exist. Yeah, it cannot. I think it cannot exist. Log -5. Yeah, it cannot exist. It will be an error. Cannot exist or does not exist. Okay. There's something about the change of property which I need to show you. The changing of change of base property. Yeah, change of base property. So you can also rearrange this. It's possible to rearrange this logarithm. So sometimes you might find this law, sometimes it's in this form. And it's still the same thing. Yeah. This you can rearrange. It's okay. It's still the same law. When you multiply, you take sort of taking the log x plus b is still the same thing as this. We just rearrange the equation. You might find something like this mostly, maybe in some papers. So while we are within the change of base property, another interesting question can be log a k b is the same as 1 over k log a b. Okay, so it's still the same thing. It's just a b over log a to k, which is the same as log a b over, we move the power behind its k, times 1, of course, because log a becomes 1, which is the same as log ab over k, which is the same as 1 over k log ab. And another interesting question is log a to the log cb is the same as b log ca. If you are interested, you can attempt this question as well, and let me know in the comments what you got to prove this. And also the other can be log ab times log cd is equal to log cb times log ad. Okay, yeah, you can attempt these questions if you are interested. You can attempt them and let me know in the comments what you got. Okay, I would advise you, maybe you can pause this video and give these problems a try, and you can resume the video. Okay, let's start with the first problem. Okay, so the first one is saying okay, let me just recall the whole question. A log c what is it, cb. Okay, a log cb is equal to b log c ca. Okay, this is the question. Okay, so let me use a different ink. So the way you can solve this problem is, since log ac, you can take it as a simple power, just as any power, like, okay, so here you can simply multiply this power by log ca, and which means what you do on the right side of the equation, you just do it on the left side of the equation. Okay, so now we have so of course this and this cancel out, so we have 1 on the right side of the equation. Now we are left with a log cb over log ca is equal to b, of course, and this, we are simply applying the property of change of basis of logarithms. For example, we see like these bases, they have the same, and this logarithm, they have the same base, which means this is the same as log a b is the same thing. Okay, I will just repeat the law itself. Let's say we have ax, it is the same as log bx over log ba. So b and b, they are the same basis. We say here it's c and c, it doesn't matter, as long as the bases are the same. That's what's important. So I have also showed you that log it was a log I forgot, a log, let me just say a log n or x is the same as x. Yeah, I showed you this property already, this property. So I'm using these two properties to solve the problem, which means so which means b is equal to b. So that's how we solve this problem. So let's okay, so let's prove the second part here. So I'm just gonna round this off and prove the second part. Okay, so for the second part, the concepts which we are applying, okay, let me just use this pen. It's just change of base. You just have to note where there is a change of base. So we need to prove that this is equal to this side is equal to this side. So, or maybe these statements hold. That's what we want to prove. So we just take the log with the same base on the same side. Here we have log a t is the same as log cb over log ct. Okay, so since these logs, they have the same basis, log a, which means we can further simplify is the same thing, where it's just the property of changing basis which we just applied. I'll just repeat it for the last time. Okay, I said ax same as log bx over log ba. So the bases have to be the same. It doesn't matter but the bases have to be the same to apply this property of changing basis. Okay, I hope this was helpful to you. Okay.